चैनल कूल गुरु पे, है ना। तो अब हम पढ़ने जा रहे हैं हाइब्रिडाइजेशन के बारे में। सो व्हाट इज हाइब्रिडाइजेशन? फर्स्ट ऑफ ऑल आई शुड राइट इट इन अ गुड मैनर। एंड व्हाट इज हाइब्रिडाइजेशन? Actually, in hybridization, what is happening here? The mixture of orbitals are available here. So we can write here. I can call it mixture of orbitals. That is hybridization. And what is the need of it? What is the need of hybridization? So what is happening here? If I am taking CH4. So here CH4 is known as methane, which is also known as biogas, and it is very famous as a biogas. And here we all know, like, this is central metal atom. Central metal atom. If you are having curiosity about to know what is central metal atom, then I will let you know that what is central metal atom. If you want to know it, then you can easily signify this. What is central metal atom? There is two significance. There is two significance. First one is, first significance is electronegativity. Electronegativity is more. Electronegativity is more. So in central metal atom should have electronegativity is more. That is first point. And the second one is the number of atom. The number of metal atom is less. So here we can see in CH4 carbon is having more electronegativity as compared to hydrogen, and carbon is in number only 1, and in hydrogen we can see 4 hydrogen atom is there. So we can easily recognize who is central metal atom. So here central metal atom is carbon. So now we are moving ahead and we are going to into the next phase. We can go ahead here only. So yes, I can move it. And what is the need of hybridization? First of all, we should know. So in CH4, now we know what is central metal atom. Am I right? So central metal atom is carbon, and we all know what is the atomic number of carbon. It is 6, and atomic mass is 12. If I will talk about electronic configuration of carbon, then we can write here through the above rule: 1s2, 2s2, and 2p2. So 2, 2, 2, that is 6, which means that is the atomic number. Here atomic number is always written in the downside of the atom, and the top side is atomic mass. So here this is the first orbit of an atom, and this is the second orbit. So this is first orbit. And what is the valence electron? That is 4 only. So we can write here in the box the orbitals. So this is 2s orbital, and this is 2p orbital. And here 2 electrons are there, so we can put it here in the opposite direction. And in 2p we can write here px, py, and pz, and we can put it into the orbital like this. And now we can see only 2 electrons are unpaired, and we all know that like whatever the unpaired electrons are available in the orbital, that much bonds can be made by the central metal atom. So if here only 2 electrons are available, which means they can make only 2 bonds. But here we can see carbon is forming 4 bonds with respect to hydrogen. Am I right or wrong? So for that we can go ahead into the next step, and here we can, this is known as actually the ground state. What is this? This is ground state. Okay, and the next part is like this. So we can provide some energy to this. So what will happen here actually in these orbitals? Now we can see this electron will jump out and it will come here into the pz orbitals. So it will do like this, 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 this. Now we can see here 4 unpaired electrons. That's why carbon is forming 4 bonds with respect to hydrogen, because hydrogen is also having 1s1, which means single electrons. Okay, so this is the chemical bonding of CH4. But what is the need of hybridization, that I want to let you know. But before that I want to tell you these things which will help you a lot to getting understand or getting your completion of curiosity for hybridization. That is the basic thing or fundamental thing to know about the hybridization. That's why I told you before the getting into next step. So now we are moving ahead. What is the need of hybridization? So here again I am writing CH4. So now here we can see what is center metal atom. We all know that carbon is center metal atom. Okay. So here carbon is center metal atom, which means yes, I can write like this. Okay. CH, 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 CH. Okay. So here we can see the distance of bond between 2 atoms. So this is known as the distance between 2 atoms. That is, this is bond. This is known as bond, and this is sigma bond. This is known as sigma bond. So here 4 sigma bonds are available. Okay. So actually what is happening here, the distance between carbon and hydrogen, the bond length of this is equal. The bond length of this is equal, which means carbon single bond hydrogen. This bond length is equal. This bond length is equal. But before hybridization, we are knowing about the VBT, that is valence bond to heat, which cannot explain that how does we can see the length of bond is equal in CH4 or methane. Okay, so for that hybridization came, and hybridization told us about how the bond length is equal in CH4, and each and every bonds are equal here, just because of hybridization. And in hybridization only we can get the answer why the CH bond length is equal or are equal. So for that we need hybridization. Okay, so now we are moving ahead. What is hybridization? So here what is happening actually in hydrogen, it is, we can write here 1s1, here also 1s1, here also 1s1, and here also 1s1, which means how many s electrons are there? 4 with respect to hydrogen. And if we talk about carbon, so here we can write what? 1s2, 2s2, 2p, 2. This is first orbit, and the next one is second orbit. So what is happening actually, like before only we have seen here, what is happening? Carbon Here this is 2s, this is 2p. So how many electrons are merged together? S is having 1 orbit and P is having 3 orbit. So here we can see 4 sigma bonds are forming here with carbon and hydrogen. And how many orbitals are intermixing with each other? That is S, 1 of S orbital and P of 3 orbital. Okay? Which means the total 4 orbitals are mixing here. 4 orbitals. 4 orbitals, and they are making actually 4 sigma bond. Which means S, only S is 1 and P is 3. So now it is known as sp3 hybridization. Okay, so if you can see 4 sigma in any molecular structure, so you can directly write the hybridization of that particular compound or molecule, which is sp3 hybridization. Okay, so I want to tell you more about this, but now I am getting stopped here. Thank you very much. Have a great day. Jai Hind, Jai Bharat, Sat Shri Akal.